we had started talking about weak acids, and I told you about organic acids, most of the organic acids being weak acids, which basically means that if you have a carboxylic acid or any other organic acid, it's not going to dissociate or ionize fully. What that basically, for example, if you have ethanoic acid, it's not going to produce a lot of ethanoate ions and a lot of H plus one ions. So if you have 1,000 molecules of ethanoic acid, that only means K, it means that probably one molecule would probably break down and produce ethanoate ions and H plus one ions. So acids are basically these molecules that end up producing these H plus one ions. That's what an acid is. And they're not going to produce a lot of them. They ionize partially. The actual reaction, as I've previously told you, the actual reaction that actually goes on is that I've previously also mentioned that there is no such thing as H plus 1. I've told you that H plus 1, whenever an H plus 1 is aqueous and it is released in solution, this H plus 1 actually goes and it bonds with the, datively bonds with the water molecule. Water has these lone pairs. So these H plus 1 ions, they datively start to bond with these water molecules to form these H3O plus 1 ions. So in reality, the ionization of a weak acid would actually look like this, that there's going to be ethanoic acid and it would react with a water molecule. It would release an H plus 1 ion, but that H plus 1 ion would datively bond with the water molecules to form an H3O plus 1 ion. So although we're going to study this, but always remember that H plus 1 aqueous, what we are actually referring to is this thing. It's H plus 1 aqueous, but natively bonded to a water molecule. So this is kind of an overly simplified equation. And this would apply to any weak acid. For example, I mean, and we've also stated that weak acids, they come in many different shapes. For example, since we are talking about weak acids, anything that is capable of producing H plus ions, that's a weak acid. For example, you have NH4 plus 1. Now, NH4 plus 1, for example, you have NH4 plus 1. So NH4 plus 1 is a weak acid. Why? Because it's going to break down and it's going to produce NH3 and H plus 1 ion. Similarly, if you have HSO4 minus 1, that's a weak acid because it's going to produce SO4 minus 2 and an H plus 1 ion if it ionizes. And I've also told you previously that negative ions, they don't usually ionize very strongly because negative ions actually attract H plus 1 ions. They don't actually produce H plus 1 ions. So acids can come in many different shapes as long as you have a molecule that is capable of releasing an H plus 1 ion. So uh, the general form of an acid could be written as HA, and it would dissociate to produce A minus 1 ions and H plus 1 ions. Okay, that's so we can generally call an acid HA. It's an H plus 1 ion bonded to something, and let's call that A. It's an H plus 1 bonded to SO4 minus 2, H plus 1 bonded to NH3, that's NH4 plus 1, or it's an H plus 1, like we can see over here, H plus 1 bonded to this ethanoic acid molecule. So all acids can be written in this form. HA, it dissociates to produce H plus 1 and A minus 1 ion, and it's an equilibrium reaction. And since it's an equilibrium reaction, if we do products over reactants, you get this expression, which is that, and this is known as the equilibrium constant Ka, dissociation constant of a weak acid. So this is known as a dissociation constant of a weak acid. Which is basically Kc, the concentration of the products divided by the concentration of the reactants, and this Kc value is a constant. Uh, and since these two ions are going to be produced in the same quantity, So that also indicates, I mean, if one molecule breaks down, it's going to produce one H plus one and one A minus one ion. So both of them would be produced in the same quantity. The concentration is going to be the same. So instead of writing it twice, you can call it H plus one squared, because H plus one and A minus one concentration are going to be equal. They're both going to be equal. So you can call this H plus one squared. And this is the formula for weak acids. The only thing you have to do for weak acids is that whenever you see a weak acid, uh, it's going. I mean, this formula is going to be applied to a weak acid. It's going to have a dissociation constant value. So there are three things that are interlinked. The concentration of H plus one ion, the concentration of the acid, and the value of Ka. Now Ka is a constant. Since it's Kc, only changes with temperature. So it only changes with temperature, like any equilibrium constant. And you'll be given two things, and you'll be asked to find the third thing. For example, over here, you're being asked to find. You're being told that the concentration of ethanoic acid is zero point 0.1 mole per dm cube. The Ka value is given, and you're being asked to find the pH. So using this formula, you can simply put the values in this formula. The Ka value is given, the concentration of the acid is given, and you can find the H plus 1 concentration, which we have already done. And taking the under root, you can find the H plus 1 concentration. And pH can be calculated by taking the negative log of 1.48 times 10 per minus 3. And you'll get your pH. So we'll just do one more question similar to this. So let's say the Ka for NH4 plus 1 is given as 8 into 10 per minus 6. And the concentration of NH4 plus 1 in solution is provided. This is given as 0.15 mole per dm cube. And you're being asked to give the value of the pH, find the value of the pH. So the first thing that you have to really figure out is how is it acting as an acid. If it dissociates, it's going to produce NH3 and H plus 1 ions. And both of them would be produced in the same concentration. So you can simply apply the formula that the Ka value would be. I mean, if I derive the formula again, it's going to be NH3 concentration into H plus 1 concentration divided by NH4 plus 1 concentration. And these two ions are going to have exactly the same concentration. So this can be written as Ka is equal to H plus 1 squared divided by NH4 plus 1 concentration. And you can put in the values over here. It's going to be K would be, it's given as 8 into 10 to the power minus 6. H plus 1 is unknown. So it would be H plus 1. I mean, this is going to be squared. Divided by NH4 plus 1, which is 0.15. And you're being asked to find the pH. कोई इसकी वैल्यू निकाले pH की क्या आएगी? Sara, is this question clear to you?
Yes, sir.
ठीक है. आयशा इसकी वैल्यू ट्राई करो निकालने की. बाकी अब्दुल्ला, महफूज. The first thing would be कोई ट्राई कर ले इसकी. मेरा ये वाला कैलकुलेटर तो ठीक नहीं है. महफूज ऑनलाइन हो? It's 8 E minus 6.
Do I give the answer?
Give the answer if you have the answer.
Okay, 1.095 times 10 to the power negative 3, which is
It's
1.1.
1 point.
1.095 times 10 to the power negative 3.
So 1.10, right?
Yes.
Okay, into 10 is per negative 3, right? The other thing is, I mean, that's the H plus 1 concentration, right?
Yes.
So you can take the negative log of
Mole. Without the units?
the units are mole per dm cube, right?
Yes.
But we are interested in finding the pH. The pH would be taking the negative log of this. So take the log and just change the sign. Did you try and find the pH?
Is it 2.96?
I think it's going to be 2.9.
Yes.
6, close to that. Okay, I mean that looks fine. So that's your pH. So the whole point is, I mean, this is just a very simple, basic question. The whole point is, all acids they're going to be represented as HA. I mean, they can be represented. For example, this NH4 plus 1 can be. I mean, it's a molecule that breaks down and produces two ions. One A and one is H plus 1. So all acids and these two would be produced in the same concentration. So the formula would be H plus 1 squared products over reactants, the ratio of the products divided by the ratio of the reactants. महफूज क्या क्वेश्चन है? महफूज चैट, अच्छा ठीक है, और कैलकुलेटर, महफूज कैलकुलेटर निकालो, ये आंसर भी क्या करो, ये चैट के अंदर ही लिख लो, ठीक है? अच्छा, the other thing is कि so we can go through this question as well. ठीक है, we're going to try and attempt past paper questions later on. So out of these three, if one is missing, you can find the third one. If two are given, and you can find the third one. So, for example, in this question, you're given the propanoic acid. You're supposed to find the propanoic acid concentration. The pH is given. So pH is given as 4.6. Now pH is given, and using pH, you can actually do the opposite and try and find the H plus 1 concentration. The K value is also provided, and if K and H plus 1 concentration are provided, so we can do a similar question again very quickly. For example, let's just, for example, as H4 minus 1 concentration, the K is given. It's given as 2 into 10 to minus 7, and your pH is provided, that the pH of the solution is given as 4.78. And you're being asked to find the HSO4 minus 1 concentration. So HSO4 minus 1 is going to behave as an acid. It's going to produce these two ions. The K expression is going to be H plus 1 squared divided by the acid, which is HSO4 minus 1 in this case. And you just have to input the values. The only value that's, I mean, you have the value of Ka. you need to figure out the H+1 concentration. So we can use pH over here. And we know that pH is negative log of H+1 concentration, and that value is given as 4.78. So we have to do the reverse to find the concentration of H+1. The first thing would be you take the negative sign to the other side. The next thing would be take the inverse log, which is simply shift and log. And that actually, the opposite of log is, if you take the inverse log, it's going to be 10 to the power minus 4.78. And if you do this on your calculator, just press shift, then you have to press log and minus 4.78. And the answer that you're going to get is 1.66 into 10 to the power minus 5. Mole per decimeter cube. So that's your concentration of H+1. And using that, you can find HSO4 minus 1 concentration, that rearranging the terms, HSO4 minus 1 concentration would be the H+1 concentration squared, which we have already found over here. So it would be 1.66 times 10 to the power minus 5 squared divided by the Ka value, which is already given in the question, and that's given as, so that is given as 2 times 10 to the power minus 7. That is already provided. And if you try and calculate this, this is 1 point. As somebody try and calculate this and tell me what the value is. Abdullah, you try करो calculate करना. Mahfouz, Aisha. Sarah, are you calculating this?
Yes, sir. It's, do I say the answer or?
What is the value that you're getting?
1.37, no, 1.38 times 10 to the power negative 3.
10 to the power negative 3. Okay, so that's your answer.
Yes.
So the whole point is, in this question, this is your formula. This is the acid. The acid could come in many shapes, but the basic idea is exactly the same. You just use this formula and you can find, if two things are given, you can find the third thing. Now, the other thing about this is, we can quickly talk about buffers quickly. Okay, so we can move on towards solving questions. There, what are buffers? Let me explain very quickly. Okay, what's a buffer? A buffer is something that is going to resist a change in pH. So you're supposed to resist a change in pH when a small amount of acid or alkali is added. Only a small amount. Now, it's going to resist a change in pH when a small amount of acid or alkali is added. Why do you need to resist a change in pH? The reason is, I told you that all reactions on planet Earth are basically happening in a medium which is called water. TK, all biological reactions are mostly happening in water. Your cells are full of them. So what type of water do you have? That's very important. So if the water has H+1 and OH ions, in equal quantity, if the solution has H plus 1 and OH ions in equal quantity, that's called neutral pH. Some reactions prefer that. Some reactions prefer that they need more H plus 1 ions and less OH ions, like your digestion reactions in the stomach. While other reactions, they prefer that there's less H plus 1 ions in the solution and there's more OH ions. So this is acidic conditions, this is basic conditions, and these are your neutral conditions. So since the medium is water, acids can increase the quantity of H plus 1 ions. If you add a basis, basis can decrease the quantity of H plus 1 ions, or vice versa, they can increase the quantity of OH ions. Now, pH is very important. Why? Because if the pH or this composition of the solution changes, the reactions would either stop happening, or those reactions which were not happening earlier, they would start to happen. So if the stomach pH changes, then your digestion reactions are going to be affected. So the point is that all natural systems and even the man-made systems, they're designed to resist a change in pH. You don't want the pH to vary, because if the pH varies, uh, I mean, for example, if your blood has a pH of 6.5, you have to maintain that pH at all cost, because if the pH becomes slightly more acidic or slightly more alkaline, the reactions that are happening in your blood and in the cells that are in the blood, they're all going to be affected. So how are buffers created? Buffers are created when you mix a weak acid plus you mix it with a conjugate base of the weak acid. So that's how buffers are created. So the question now is, what's a conjugate base of the weak acid? It's usually the sodium salt of the weak acid. As a so as a sodium salt of weak acid. So for example, ethanoic acid is a weak acid. So if you remember Bronsted-Lowry acid base theory, so your weak acid would dissociate, ionize, and it would produce this A minus 1 ion, which in this case is this ethanoate ions. Every weak acid is going to have a corresponding conjugate base. Why is this referred to as the conjugate base? Because in the reverse direction, this ion is capable of gaining H plus 1 ions. I mean, if you think of the reaction in the backward direction, then you're going to notice that this ion over here would gain H plus 1 ions and it would form ethanoic acid. In the forward direction, this is behaving as an acid because it releases H plus 1 ions. Hence, every acid has a conjugate base. And also remember, weak acids usually have strong conjugate bases. I mean, this is the reason why the reaction is not going in the forward direction. This is the reason why ethanoic acid is not dissociating, because the base that is formed has a very strong negative charge. So this negative charge over here is very strong, and this is the reason why the H plus 1 gets attracted to it and it forms the ethanoic acid back again. So it's not going to ionize. So whenever you have a weak acid, that means the conjugate base is very strong, because if it ionizes, so it's such a strong conjugate base, it's going to attract the H plus 1 back again and it would form ethanoic acid back again. So is this point clear?
Yes, sir.
I said, so what's a buffer? A buffer is something that is going to resist a change in pH. So, I mean, this is an equilibrium reaction. Even if let me remove. So this one is an equilibrium reaction, and it's very capable of acting as a buffer. Why? Because if I increase H plus 1 concentration, Le-Chatelier principle suggests that if you add more H plus 1 ions into the solution, into the mixture, backward reaction is going to be favored because it's going to try and decrease H plus 1. So automatically what would happen that if you increase H plus 1 concentration, then that means that backward reaction, so that means backward reaction is favored. And equilibrium shifts to the left. Okay, this is basic Le-Chatelier principle. Whenever you increase concentration of a substance, the equilibrium would try to decrease the concentration of H plus 1 ions by changing it into ethanoic acid. So equilibrium shifts to the left. And if it shifts to the left, if it shifts to the left, then H plus 1 would decrease. And vice versa. So that means it's resisting a change in pH. I mean, it's not letting the H plus 1, I mean, it's very hard for, it's resisting the change in the quantity of H plus 1 ions. Vice versa, what we can do is if we decrease H plus 1 ions, the Le-Chatelier principle states that if you try to decrease the quantity of H plus 1 ions, like if you try and neutralize them, then the equilibrium would try to make more H plus 1 ions. So it's going to dissociate more and it's going to produce more H plus 1 ions. So it's trying to do the opposite. It's not letting you change the quantity of H plus 1 ions. No matter how you try to change the quantity of H plus 1 ions, uh, it's going to resist a change in the quantity of H plus 1 ions. Sarah, do you get this point?
Yes, sir. So like if the H plus increases, so it will shift to the backward to reduce the H plus.
Exactly.
Okay.
I mean, do you understand the Le-Chatelier principle point over here? Is this clear?
Thank you. Yes.
But the thing is, although it is an equilibrium reaction, and it can go in the forward direction, it can also go in the backward direction, depending on what you're doing with the H plus 1. Okay, so if you try to increase H plus 1 ions, it's going to try and decrease H plus 1, it's going to favor the backward reaction. If you try to decrease H plus 1 ions, it's going to make more H plus 1 ions by favoring the forward reaction, right? But the whole issue is that this backward reaction would not actually, in reality, it would not actually be possible, or even though it's an equilibrium reaction. And the reason for that is that since it's a weak acid means that if you have 1,000 molecules of ethanoic acid, very few molecules are going to dissociate or ionize. Let's say two molecules break down and they produce two ethanoate ions and two H plus 1 ions. So the problem is that ethanoic acid is present in a very large quantity. So going forward or moving in the forward direction is not an issue. Like if you want more H plus 1 ions to be produced, you have 1,000 ethanoic acid molecules. So more of them are going to break down and they are capable of producing more H plus 1 ions. Okay, Sarah, is this point clear? That there's no issue in the
Yes, sir.
form. I said, but going in the backward direction is kind of difficult. Why? Because let's say I add 50 H plus 1 ions. Like I add something that is acidic and it produces more H plus 1 ions. So immediately the reaction wants to move in the backward direction, but it can't. The reason it can't move in the backward direction is this thing would be acting, it would limit the reaction. Why would it limit the reaction? Because if 50 H plus 1 are to react and they want to go back in the backward direction, it's 1:1. So 50 H plus 1 would need at least 50 ethanoate ions to react with. So we can add this over here, 50 H plus 1 need at least 50 ethanoate ions. to go in backward direction. So right, is this point clear, Sarah?
Yes, sir. So it can't go backward because it's less.
I mean, like if I add
Yes,
if I add extra 50 H plus 1 ions, now Le Chatelain principle states that the reaction should go in the backward direction, right? But
yes,
50 H plus 1 need at least 50 ethanoate ions to react with, and then they can go in the backward direction, right?
yes,
So the main point is the quantity of ethanoate ions in the solution is limiting the whole reaction. I mean, it can go in the forward direction. I mean, if it wants to move in the forward direction, there is no issue. You have lots and lots of ethanoic acid molecules, and they can dissociate and they can produce more H plus 1 ions. But if you want to reduce the quantity of H plus 1 ions, and if the reaction wants to go in the backward direction, it would not be able to go in the backward direction because the extra H plus 1 would need lots of ethanoate ions to react with. So what you do is, so Sarah, is the whole point clear why this cannot act as a buffer at the moment?
yes, sir. Because it will limit the.
Okay, so
Yes,
I mean the problem is it's not going in the backward direction. I said, so what if I have 1,000 molecules of ethanoate ions instead of two? Now there's no limit. I mean, now if I add extra 50 H plus 1 ions, you can, I mean, there are lots of ethanoate ions present. So 50 H plus 1 ions can react with 50 ethanoate ions to go in the backward direction. So I need to somehow increase the quantity of ethanoate ions. But where would I get those ethanoate ions? Because I'm not getting those ethanoate ions from the ethanoic acid over here because it's a weak acid. Weak acids, they don't ionize, they don't break down, they don't produce these ions or in a large quantity. So I need to add these ions from the outside. Hence, a buffer is not just formed with a weak acid, but you should add extra ethanoate ions into the solution, and then it's going to act as a buffer, which is your conjugate base. So it's a mixture of the weak acid, but at the same time you need to increase the quantity of ethanoate ions in the solution. Uh, so you need to increase the quantity of ethanoate ions in the solution, and when you have more ethanoate ions, then the reaction can happen in the backward direction. ठीक है? I'll just hold on 1 minute. ठीक है? For the azan. So I was talking about ethanoate ions, and it was acting as a limiting reagent over here. And you would have to add this conjugate base because they need to be added from outside. You can't add ethanoic acid and expect that ethanoic acid is going to dissociate and produce ethanoate ions because it's a weak acid. Weak acids don't produce a lot of ethanoate ions. So these ions have to be extra ions need to be added into the solution. And where can you get those extra ions? They can be you can add a you can add the sodium salt of the weak acid because that sodium salt contains ethanoate ions. Or it could be any salt that is soluble. Actually, is this clear? Sara, is this clear? Bakiyon clear hai? Aisha, is this clear?
yes, sir.
Now, the problem with the whole expression now would be, okay, I'm going to change the expression for Ka. I mean, K was exactly the expression that was used for this particular reaction. It was ethanoate ion concentration into H plus 1 concentration divided by ethanoic acid concentration, right? I mean, this was the expression for Ka. Previously, we would write H plus 1 squared. Why? Because we used to think that these two ions especially these two ions, they were present in equal concentration. But if you're dealing with a buffer, in a buffer, this ion has more concentration because you've added extra ions into the solution by adding a salt. So so that the reversible reaction could happen freely. Both forward and backward can happen freely. Now the thing is that these two ions, the H plus one ions and the ethanoate ions, are not going to be present in equal quantity because the ethanoate ions, you're getting most of your ethanoate ions from the salt. So your expression for Ka, which is going to be pretty much the same, except that you're not going to write H plus 1. It's going to be salt concentration into H plus 1 concentration divided by the acid concentration. Salt over here refers to the conjugate base. So salt over here, it refers to the conjugate base that we are talking about. So that's going to be your new expression for Ka. Okay, this over here is going to be your new expression for Ka. The previous one was H plus 1 squared. Okay, here's the previous one. It was simply H plus 1 squared divided by the acid concentration, but now you're not going to square H plus 1. Instead, this ion over here, you're getting most of the ion from the salt, so you're going to write the salt concentration T. Sarah, is this clear?
Yes, sir.
So, we're going to continue from this in the next class tomorrow. Okay. So, okay. Take care, Hafiz.
Allah Hafiz.